G'day ladies and gents, this is Kai for Taught Gaming. Today we're going to look at the Cartesian coordinate system, how to perform certain operations in it, and why it is used so often. So first, what is this coordinate system? It's actually the standard system used in pretty much every game and 3D environment due to its simplicity when performing simple operations. This system has three components, the x, y, and z components. For those who know vectors, these components have quote-unquote unit vectors, I, j, and k respectively, and those three vectors, along with the point 0, 0, 0, form the system's base. In the Cartesian coordinate system, these three components have the particularity that they are all perpendicular to one another. We first need to know what these directions are though. This is the x direction in red, this is the y direction in blue, and this is the z direction in green. We can also say that there are three planes in the system, the xy plane, the xz plane, and the yz plane. When we have a point, say this one, we can define it with three parts. This point, for example, is 3 blocks in the x direction, 5 blocks in the y direction, and 2 blocks in the z direction. So, we can say that this block is at the point 3, 5, 2. Now let's look at some operations that can be conducted in this coordinate system. First, let's look at mirroring across a plane. Let's mirror this block across the xy plane. All that needs to be done is to simply multiply the z value of this point by -1, which means we now have a point at 3, 5, 2, which is here. The same process can be repeated for any other plane. If we mirror across the xz plane, then the y value is what needs to change. If we mirror across the yz plane, then the x value is what needs to change. Now, what about rotating a point? For the sake of simplicity, we will only be rotating 90, 180, or 270 degrees, and only in 2D. Let's redefine our system and say that green is in the x direction, and red is in the y direction. If we want to rotate this point 2, 3 about the origin 90 degrees, our new values for x and y, which we will call x prime and y prime, are as follows. For those of you who know sines and cosines, you can do any rotation value with these equations. Simply substitute your desired theta value. But for those of you who don't know sine and cosine, for a 90-degree rotation, your initial point at xy becomes -yx after the rotation. On screen are the simple equations for all 90-degree rotations. Note that 90 degrees counterclockwise is the same thing as rotating 270 degrees clockwise. So back to our point at 2, 3. If we rotate it 90 degrees, we will end up with our new point at -3, 2. If we have a larger structure, like some we often see in Minecraft, and we rotate them with an external tool like WorldEdit, these same rotation equations are being used on every single block in the build. Now, you know how they work. The Cartesian coordinate system is the most used system since it's particularly good for 3D modeling, CNC, and robotics applications. There are other coordinate systems that are used for different applications too, some being the cylindrical and spherical coordinate systems. Usually these are used in higher level mathematics to calculate the integrals and derivatives of functions more easily than in the Cartesian coordinate system. That's it for the Cartesian coordinate system. Thank you for your attention. I hope you learned something.